Welcome to the last part of work, energy and power. In the previous video, we looked at work, energy, uses of energy, and environmental impacts of energy. In this video, we're going to take a look at conservation of energy and power. Let's get started. So before we can start studying conservation of energy, there are two types of energies that I want us to concentrate on. The first is called potential energy and is defined as the energy by the position or state of an object. So the potential energy depends on the position of an object. The potential energy due to height is called gravitational potential energy and is given by PE is equal to mgh, where PE stands for potential energy, m is mass in kg, g is gravitational acceleration, and h is height. The units for potential energy is just a type of energy, so that they are the same units as energy itself, which is joules. So the height that I'm referring to in this formula is, let's say we have got this block here, and on top there is a ball. So the height is the distance from the ground to where the ball is. So when you think of potential energy, think of something like this. If this falls, so this energy, if this falls, let's say if we have something on its path, it can push that something, so work is going to be done. Remember, energy is the ability to do work. So potential energy is determined by the position of an object, and this is the h that I meant in this equation. Let's take a look at an example. A 20 kg object is raised to a height of 5 meters. What is its potential energy? Here's the solution. The data. Mass is 20 kg, height is 5 meters. We're looking for potential energy, which is given by mgh. So we can plug in the values. M is 20 kg, g is 10 as usual, h is 5, and we're going to get 1000 joules. The next type of energy is kinetic energy, which is kind of the opposite of potential energy and is defined as the energy due to the motion of an object. So kinetic energy is basically the energy that is possessed by objects that are moving. The formula for kinetic energy is half mv squared, where Ke is kinetic energy, m is mass, and v is velocity in meters per second, mass in kgs, and kinetic energy is going to be in joules since it's just a type of energy. Let's take a look at an example. A 2 kg stone is thrown with a velocity of 5 meters per second. What is its kinetic energy? Here's the solution. So here's the data we've been given. Sorry for this. Mass is 2 kg, velocity is 5 meters per second. We're looking for kinetic energy, which is given by half mv squared. You can plug in the values. So m is 2 kg and v is 5. When we do this, we're going to get 25 joules. So this is the kinetic energy of the stone. Now we start conservation of energy. So conservation of energy is a law which states that energy can be changed from one form to another, but cannot be created or destroyed. So if you have eaten food, if that food gives you 100 joules of energy, whatever you do, you cannot destroy that energy and you cannot create more energy. What's going to happen is you are going to be changing that energy into other forms, but the total sum of energy is going to be the same. So let's take a look at two cases which analyzes conservation of energy. The first is throwing an object. So let's say this ball here, let's say this is a mountain, or it can be a house or anything. So if this Mr. Man is about to throw this ball here, so the potential energy before the ball is thrown is 1000 joules. The kinetic energy is 0 joules. Remember, potential energy depends on the height and mass, but here we're going to assume the mass is constant. So the height from here to here is what determines potential energy. The higher you go, the higher the potential energy. The lower you go, the lower the potential energy. So as soon as this ball starts going down, the potential energy is going to be reducing because the height is also reducing. However, the velocity here was 0. So as it is falling, the velocity is increasing. What does that mean? Remember, kinetic energy depends on the velocity of an object, half mv squared. The higher the velocity, the higher the kinetic energy. So as this is falling, the velocity is going to be increasing, which implies that the amount of kinetic energy is going to be increasing. As the ball is halfway, the amount of potential energy and the amount of kinetic energy are going to be equal, but the total will still be the same because energy cannot be created or destroyed. Potential energy is going to be lower, kinetic energy is going to be greater. At first it was 0 joules, now it's 500 joules. So when this ball is about to hit the ground, it will have the maximum velocity, meaning that it's going to have the maximum kinetic energy, which is 1000 joules, and potential energy is going to be 0 joules. When it's about to hit the ground, we can assume that the distance from the ground to where the ball is 0. But as soon as it hits the ground, all the potential energy is going to be restored, because potential energy is the energy of an object that's not moving, and the kinetic energy is going to be 0. But the point is the total energy remains the same. So you should learn to see this conservation of energy, because good questions can be structured from here. For example, you can be given a potential energy of an object, then you can be asked to find the velocity when the object is about to hit the ground. So what do? You get the potential energy, and you know that the value of the potential energy is the value of the kinetic energy here. So use the formula for kinetic energy. The potential energy you have been given is going to become your kinetic energy. Then you equate it to half mv squared. The mass you're going to be given, the velocity is what to calculate. Once you get the velocity of then you are done. The second case is the swinging pendulum. So at this point, the pendulum is about to be released. So here it is at its maximum height from the ground. So this bob of the pendulum has the potential energy. In this case, let's assume 10 joules. The kinetic energy is 0 joules. So once it's released, it's going to be moving. As it is moving, the velocity is going to be increasing, the height is going to be reducing since it's going towards the ground. Therefore, the potential energy is going to be reducing and the kinetic energy is going to be increasing. At this point, the kinetic energy is going to be at its maximum because it is at its maximum velocity, while the potential energy is 0 joules. Then as it keeps going up again, the potential energy will be increasing while the kinetic energy will be reducing. When it reaches here, it will stop momentarily as it is about to go back. So the potential energy will be at its maximum, the kinetic energy will be 0. So this is the conservation of energy. Sorry for that. Finally, we look at power. What is power? Power is defined as the rate of doing work. When a person, they have power, then they should do a given amount of work in a short time. The unit of power is watt, represented by W. Power is a scalar. The formula for power is work done over time, or energy used over time. Work done over time, or energy used or consumed over time. So you can use this part or this part depending on the question. If they have given you energy, you can use this part. If they have given you work, you can use this part. So P is power in watts, T is time in seconds, E is energy in joules. Here's an example. A crane can lift 200 Newton weight to a height of 100 meters in 20 seconds. What is the useful power of the crane? So let's collect the data. Force is 200 Newton, distance is 100 meters, time is 20 seconds. But the formula for power is work over time. Do we have work here? We don't, but we do have time. But using this information that we have been given, can we get work? Yes, because the formula for work is F times D. So we can use this to get work. Then when we do that, we can now use this formula for power. So the formula for work is F times D, like I said. So if we plug in the values, 200 newtons times 100 meters is going to give us 20,000 joules. With this 20,000 joules, what we can do is we can apply the formula for power, which is W over T. So W is the work, 20,000 joules, T is the time, 20 seconds. When we divide, we're going to get 1,000 watts as the power. So this marks the end of this topic. Hope you have learned something. Happy solving.